Hello student, my name is Surbheet Shukla and as I am assistant professor in Rama University. Today we are going to discuss about the compiler design. The compiler design is one of the important topic in the field of computer science and engineering. In the computer science, the one of the important topic, the phases of compiler we are discussing. So let's start the phases of compiler. These 6 phases are present in the compiler and these 6 phases are the complete syllabus of our compiler design. So we are discussing one by one. The firstly we are discussing about lexical analyzer. The lexical analyzer is the one of the important stream in the compiler design in which the source program is taken as a input. Source code is taken as an input and this source code is now break into the form of tokens. In the lexical analyzer, the one of the main objective that the source code is break into the pieces of token and the token is taken, you can see in this example, we are taking a small source code where S is equal to A plus B multiplication by C. In the lexical analyzer, we are breaking these code into the form of token where S is taken as ID1 and A is taken as ID2 and B is taken as ID3 and C is taken as ID4. Means then each values having break into the pieces of token. So what we do in the lexical analyzer, we are taken source code and break into the form of tokens. So in the lexical analyzer we are doing tokenization. In the second phase we are discussing that syntax analyzer. In the syntax analyzer, the token which is getting from the lexical analyzer, now we are breaking the lexical analyzer is converted into the form of parse tree. In the second phase, we are converted the token comes from lexical analyzer into the parse tree. As we learn in the theory of computation about the parse tree, so we are discussing again the source program is converted in the form of tokens. Now the tokens is converted in the forms of parse tree where the ID1 is taken as a root node and the equal to is taken as central root node and the plus 1 is taken as the root node of ID2 and multiplication and the multiplication takes as a root node of ID3 and ID4. These parse tree is created. After creating this parse tree, the another phase, the third one phase is semantic analyzer. In this semantic analyzer, the parse tree comes from the same syntax analyzer is now converted into the meaningful forms. Means the source code is identify the meaning of each operator and operand. After declaring each value of operator and operand, we are taking this meaningful source code and put into the intermediate code generation. So what we do in the third phase of compiler, phases of compiler, the identification of meaning identification. In the fourth phase of compiler, the intermediate code is the name intermediate code generation. In the intermediate code generation phase, the data comes from semantic analysis. The source code comes from the semantic analyzer is converted into the intermediate code. The intermediate code or 3 address code. In this intermediate or 3 address code or 4 address code is now as work as mediate code. Now this intermediate code is now converted into the and transferred to the code optimization layer or code optimization phase. Now the intermediate code comes in the code optimization phase. In the code optimization phase, the data or the source code is optimized. Why we are doing this? The main objective of the code optimization phase is to minimize the size of our source code and maintain the space and the time complexity of the particular program. Why we are doing this? The one of the important reason is to improve the size of the particular program and improve the time efficiency and space complexity of the particular source program. So this phase also increase the overall efficiency of the phases of compiler. After optimizing the code, after minimizing this code or optimize this code, now we are transferring this code to the code generation phase. In the code generation phase, the source program or minimized source program now is converted into the target code. Target code or machine code. The code which is understandable by the machine. In the first phase, Lexicon Analyzer, the source code is converted into the form of tokens. Now these tokens are taken and transferred to the syntax analyzer. In the syntax analyzer, the hierarchical structure is created, means the token is structured in the form of parse tree. So where we are mentioned there is parse tree. After completing the parsing, now we are this transferred to the semantic analyzer, where the meaning of the parse tree is defined. After identify the meaning of the particular parse tree, these code and these source code are transferred to the intermediate code generation. In this intermediate code generation, our intermediate code is created. I give you an example. We are creating a compiler for the particular language, A language, but the compiler is built of the language B. The language B compiler, if we are taking the data in the form of A language, so it will be converted in the form of B data language, because the machine is able to understand the language of B, because the compiler is written in the B language. Okay, so that's why we are converting into the intermediate code form. In this phase, we are going to easily convert these intermediate code directly in the form of machine code. But for increasing the efficiency of particular process or for increasing the efficiency of compiler, now we are taking the intermediate code and transfer to the code optimization. In the code optimization phase, the whole program or whole source program in the form of intermediate code is optimized now. It reduces the size of your program and it will increase your time complex, it will increase your efficiency of the program and reduce space as well as time complexity of the particular program. After code optimization, we are transferring to the code generation phase, which is sixth phase of phases of compiler, in which the source code or optimized code is converted into the machine code. This is all the phases of compiler. As we discussed in the phases of compiler, the main use of the compiler is to convert your source code into the machine code. It is one of the main objective and aim of your compiler. We are discussing about the two things, the compiler and the interpreter. Both having same hierarchy, both having same structure, but the way of working is different. If we are talking about the compiler, or interpreter, compiler and interpreter, compiler is used to execute whole program at a time, and the number of errors occur in the particular program are reflected after the full compilation of your program. But when we are talking about the interpreter, the interpreter is read line by line of your program. Means if we are comparing compiler and interpreter, the efficiency of both, if we are talking about the interpreter efficiency is more, but it takes much more time, time complexity is comparatively high as comparison to compiler. So these are the two types of compiler. Now we are discussing more about the intermediate code generation. Why we are discussing about this? Because this is one of the most important topic and most asked topic in the examination. So we are more discussing about the intermediate code generation. The intermediate code generation is a kind of conversion of your source program into the intermediate code. So why we needed to convert the upper source program to the intermediate program? The one of the most important reason, because let us suppose that we are going to build a compiler for Python programming. If we are building a program for the Python programming and our compiler is written in the form of Java, but just let us suppose the program which is written in the form of Java, so the system is unable to understand the language which is written in the form of Python. So what we do, one thing we are taken, the source, the code which is taken in the Python now is converted in the form of Java. The why we are one of the reason behind that, because the compiler is written in the form of Java programming language. So the system is unable to identify the meaning of Python. So what we are taking our source program in the form of different programming language is now converted in the form of Java. And when the code is converted in the form Java, the compiler is able to identify the complete meaning as well as complete execution of the system. And this code is known as intermediate code or intermediate code generation phase. In this topic, we are discussing about the 3 address code, 4 address code, and the different methods to understand the each and every concept of compiler design. Okay, thank you and happy learning.